in example 4, they want us to take these functions and find their integrals by interpreting them in terms of their areas. So they want us to graph the function and look at the graph and approximate the area that way instead of doing all the calculations. So if we look at part A, let's think about what a graph of that would be. So this is what we're trying to graph, which I'll call y. And it's the positive square root. There's no plus or minus in front of it, so that just means the positive one. If I square both sides, I get y squared equals 1 minus x squared. If I add x squared to the other side, I get this. And this is the equation of a circle. So they've given me a circle, but remember it's just the positive side of the circle. And this is radius 1. So if we draw a circle of radius 1, but they just want the positive, it'd be the semicircle. And then, so that's the function that they give you. And then they want the area from 0 to 1. So they want this area here. And so if you think about the area of the whole circle would be pi r squared. But here we're only looking at a fourth of it. So we're only looking at one quadrant of the circle. So 1/4 pi r squared. And my radius is 1 because it says equal 1. So we get 1/4 pi 1 squared, or pi over 4 is the area. So that was just using area equations. Part B gave us a linear equation. So let's graph the linear equation. Okay, so we're going to start at -1 for the y-intercept, and it has a slope of 1, so up 1 over 1, up 1 over 1, up 1 over 1. And they want the area under the curve. So what we've got here then is I've got this area from 0 to 1 is negative, and it's a triangle. And then I've got this area here, which is above the x-axis. So that's a positive area, and it's also a triangle from 1 to 3. And so let's call this area 1. And that's 1/2 base times height. And the base is 1 and the height is 1. So this has an area of 1/2. But it's negative because it's below the x-axis. And this area, if we've got a triangle, 1/2 base times height, the base is 2, the height is 2, so we get an area of 2, and it's positive because it's above the x-axis. So what we should have is, if I call that area 2 minus area 1 because it went below, 2 minus 1/2, we should get 1.5 for the area. And that was just using the area of a triangle equation.